So as general motivation for hash tables, if you think about a linked list, you have some a head or a start of your linked list, and to find data inside that linked list, you actually have to step through every single element. So is this it? 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 And that becomes inefficient. That actually becomes O of N. Because you might, worst case, you have to check every element once, and then what if it's not even in the list? So can we improve on that? Yes. So what if we do a binary search tree? So in this case, you have a root, where all the data to the left is less than the root, and all the data to the right is greater than the root. So what we're going to actually do is, for every element that we check, if we check the root, then we can cut off half of the data, and we don't have to check, we might not have to check this half if it's smaller. And then when we get here, we don't have to check this half if it's greater. So you're cutting the data in half each time. So it's not O of N to check for, to find an element inside a binary search tree, but you still have to make steps to the tree. So this is actually find inside binary search tree is going to be O of log N. Okay. So if you remember way back when you first learned to program, everything got put into arrays. And arrays, accessing the nth element inside an array actually has big O of 1. So wouldn't it be nice if we could figure out a way to store objects and elements inside our array and be able to access them in O of 1 in runtime of in constant runtime. So let's start defining a few things. So if we have objects, then what we want to do is we want to somehow turn that object into an integer. So an integer that can map into our array. So a hash function takes an object and in some way it's going to map into an integer. So quick ways to do that: if we have a string ABC, then a hash function for a string could be the ASCII value of A plus the ASCII value of B plus ASCII value of C. So whatever 97 plus 98 plus 99 is, that'd be the hash function that you get. Right? So how Java does this default is the hash function is going to be the address of the object. Okay. So it's the perfect hash function. It's guaranteed that every object is going to hash to a different spot, a different number. So there's not, because you could have the case where if you do this kind of hash, then the string A, D, this is going to have the same hash value because you're doing 97 plus 97 plus 100. So you're offsetting, you're subtracting one from here and adding one to here. So these two strings will actually conflict or collide when we try to insert it into the hash table. Now, the only problem is that, let's say I have a hash table. This is my hash table, and I want to put this string inside here. So that 300 minus 1, 2, 3, 5, 6. So this is 294. So the string ABC should go in the 294th index of my array. However, I only have this many indices, or this many buckets. So 2, 4, 6, 7. Let's make it easy. 8, 9, 10. Okay, so for a compression function, what I can do is I want to fit this number inside my array somehow. So what I can do is if my hash function, so let's do hash function of object O. So hash function of object, and I want to fit it inside my table. And what I can do is I can mod the hash what's returned by the hash function. I can mod that integer by the length of the table. So array.length. So what this is going to do is this is going to guarantee that any integer that gets returned back is going to map to a specific index inside my hash table. However, you'll see that it's a problem if, let's say that I have the case that 294 but 294 so hash function returns 294 for a certain object. What happens if the same hash function returns 194 for another object? You can see that if we mod by 10, that's going to equal 4, and mod by 10, this also equals 4. So in both cases, even though they have a different hash value, the hash function returns a different thing, I'm still trying to put both of them in the fourth index of the array. So how are we going to handle collisions?